L2 is that one, isn't it?
Yeah, this
No.
one. And
L2
this
is that one?
No, this one.
What page is that one?
This one is BPL9.
Oh, BPL9 is the one I showed you earlier. Yeah, right, using microscopes, metric system, powers of 10, and cell sizes. Okay. Okay, come on up to the front again. Let's just do some of these on the screen, and then I'll send you back to your desk to do them yourself. Come on up. You can get those later. Come up. Don't make me wait. You can fumble around and find them when you get back to your desk. Okay, so here's the powers of 10. Powers of 10 are also known as what? Orders of magnitude. Now let's see if you understand the concept of orders of magnitude. See how tall this pen is? How many orders of magnitude taller than this pen am I, roughly? How many orders of magnitude? 20 orders of magnitude? No, look, there's about 10 of these in my height, right? There's about 10 of these in my height. So how many orders of magnitude taller than this pen am I? No, not 10. No one ever taught you this. I'm 1 order of magnitude. I'm 1 power of 10 taller. Okay, say that. I'm 1 power of 10 taller than this, so I'm 1 order of magnitude taller than this pen. And let's say the height of my little finger. How many orders of magnitude taller than the height of my little finger am I? Or maybe the height of, let's say, this eraser or something. I guess I didn't bring my eraser, but anyway, the height of my, well, couldn't you put about 10 of my fingers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you put 10 fingers in this and 10 of these in me. So how many orders of magnitude taller than my finger am I? 2. I'm 2 orders of magnitude. 10 times 10. So scientists talk in terms of orders of magnitude, like astronomer. An astronomer might say the sun, I don't know what it is, sun is, 10 orders of magnitude heavier than the earth, or something like that. Or a biologist might say that a bacteria is whatever it is, 12 orders of magnitude, shorter than a human body and stuff, and things like that. Okay, so here's the powers of 10. Here's single things. Name these prefixes. Deca, hecto, kilo, mega, and then going this way we have a tenth is deci, centi, milli, and micro. Show me with your hands. How long is a meter? Show me with your hands. 3 inches longer than a yard. How big is a centimeter? Width of your little finger. Okay, how big is a millimeter? Thickness of a credit card. How big is a decimeter? Width of your hand. Okay, memorize those. Now, to convert from one unit to another in the metric system, let's do this problem. 1 centimeter equals how many millimeters? What's the obvious answer? 10. Look, here's a centimeter right here. See, width of my little finger? And these are the millimeters right there. There's 10 little millimeters in every centimeter. But these will get harder in a minute, so you have to know the algorithm. You have to know what's an algorithm? A systematic way to solve a problem? Say that. An algorithm. So the algorithm for these works like this. You take, first of all, the number in the quantity. What's the quantity in this problem? What's the quantity being talked about in this problem?
The quantity is 1 centimeter. Is that what you're talking about?
Yeah, you know this already.
Oh, sorry.
You be quiet.
The additional quantity?
What's the Just the quantity, period. There's only one quantity in this problem. What is it? 1 centimeter. Can you have a quantity without a number? If I say eggs, is that a quantity? No. But if I say 12 eggs, that's a quantity. Say that then. The quantity will obviously be whatever has a number. So what's the quantity here? 1 centimeter. So what you do is you write the number in the quantity with the decimal starting here, and right now we'll just cheat and use placeholders. In a little bit we'll start using let's put placeholders like this. Now you know you can put numbers to the left till you're blue in the face, no problem. Technically you're not supposed to put zeros to the right. Why? Because that's implying more significant digits. That's implying more and more precision. That's highly dishonest in science to start writing digits to the right. Highly, highly dishonest and very dangerous in engineering to imply that you have more precision than you really do. But for the moment we'll cheat and just use these as placeholders. So you write the number with the decimal starting where it starts, and then you find the prefixes. Okay, what are we going between? Talk to me. Centi and milli. So centi's right here, milli's right there. How many powers of 10 between them? 1. So you're going to move the decimal 1 place. Which way? To the right. Okay, how do you figure this out? 2 ways. You can figure it out with a thinking approach, or you can figure it out with a cookbook approach. The thinking approach works like this. We were asking how many little things, millimeters, are in a bigger thing. And there's lots of little things in a big thing. So the answer is going to be lots. Or in other words, a big number. And how do you make numbers big? Move the decimal to the right. Okay, let's say this out loud with kinesthetics so it sinks in case you're rusty on it. We're asking how many little things, millimeters, thickness of a credit card, are in a bigger thing, the thickness of my finger. And keep talking, there's lots of little things in a bigger thing, so the answer is going to be lots. Or in other words, a big number. And you make numbers big by moving the decimal to the right. Okay, that's the thinking approach. The cookbook approach is this. You simply put an arrowhead on whichever prefix is in the quantity. Say that. It tells you right here. Read it. Put an arrowhead on the prefix in the quantity. What's the quantity? 1 centimeter. So what's the prefix? Centi. So put an arrowhead on centi, and it tells you automatically to move it to the right 1 place. So move this to the right 1 place, put a new decimal there, and there's your answer, 10. Okay, let's do the next one. 1 decimeter equals how many centimeters? Let's do this as a kinesthetic. Talk to me. 1 decimeter is how many centimeters? What's the answer? 10. Okay, but let's use the algorithm. What's the first step? Write the number that's in the quantity with the decimal starting where it starts. Put in the placeholders. Okay, what are we going between? Deci and centi. So deci, centi. How many powers of 10 between them? 1. So move the decimal 1 place. Which way? Let's do this one last time. Talk to me. We're asking how many centimeters are in a decimeter. So we're asking, talk with me, how many littler things are in a bigger thing? Lots of little things in a big thing. So the answer is going to be lots, or a big number. So move the decimal to the right, or use the cookbook approach. What's the prefix in the quantity? Deci. It's the one next to the number, obviously. So put an arrowhead on deci right there. See, and it tells you to move it 1 place to the right, 1 place to the right, and you get the answer 10. We'll do one more with you here. One millimeter is how many decimeters? Well, let's just use the algorithm. 1, so 1 with the decimal starting here. Here's the placeholders. Here we go, talk to me. We're going between milli and deci. So here's milli, here's deci. How many powers of 10? 1, 2. Differ by a factor of 10 times 10 or 100. So move the decimal 2 places to the what? Oh, we have a disagreement here on which way to move it. Here we're asking how many decimeters are in a thickness of a credit card. So we're asking how many big things are in a small thing. Well, what's the general answer to that? A small fraction of a big thing is in a small thing. So the answer is going to be a small fraction. How do you make small fractions? Move the decimal to the left, or use the cookbook approach, put the arrowhead on milli. So put the arrowhead on milli, that's the prefix in the quantity, tells you to move it 1, 2 places to the left, 1, 2, 0.01. Okay? You now go to your desk and with a pencil, in case you make a mistake, go solve all 7 of those quickly. Can you hit that light for me? Turn that light on.